Okay, let's unpack this myth we all kind of learned, right? The year is 1492. Columbus discovers America, supposedly finding this, sparsely populated wilderness.
Right, but that whole narrative,
Yeah.
it was really convenient, wasn't it? For justifying conquest, suggesting Europeans brought civilization to some empty, backward place.
But what if the continent he actually encountered was already humming? Home to massive, complex, sophisticated civilizations, maybe even rivaling or, surpassing contemporary Europe in some ways.
Well, that's what the modern archaeological evidence is telling us, especially now with powerful new technologies like litter. It's forcing us to completely abandon that old story.
And that's exactly what we here at the Urban Herald want to dig into today, this deep dive. It's our look at the latest research that's basically rewriting the history books on the Americas before, say, 1492.
Yeah, confronting that colonial narrative.
Yeah.
The one built on, well, blindness and, frankly, catastrophe.
We're pulling insights from all over the Incas, high up in the Andes, down to these incredible, almost hidden garden cities in the Amazon.
And the scale. I mean, just think about this number. By 1492, estimates put the population at around 60 million people across the Americas. 60 million.
60 million, wow.
Speak something like 1,200 different languages. To put that in perspective, that's basically the population of Europe at the time.
Matching Europe's population.
Pretty much, spread across a much larger and often, frankly, far more organized landmass.
Yeah.
So this wasn't some new world. It was an ancient, thriving, global power center in its own right.
It's really hard to wrap your head around that density, 60 million people, especially when the story we usually get is, small, nomadic groups wandering through endless forests. So if that many people were here, why did the Europeans who came later, the settlers, the writers, describe it as this vast, empty, untouched land?
That right there is the tragedy. It's what we call the colonial blind spot. The Americas seemed empty because, in many places, they had already been tragically, almost unimaginably emptied.
You mean because?
Disease. The arrival of Europeans, and more critically, the arrival of Old World diseases they carried, triggered what historians now pretty much universally acknowledge as the single greatest demographic disaster in human history.
Right, the diseases the indigenous populations had just no immunity to. Smallpox, measles, typhus. The list goes on.
Exactly. And these weren't just isolated outbreaks. They came in waves, often moving much faster than the Europeans themselves. They traveled along existing indigenous trade routes, maybe even carried by escaped domestic animals.
So the germs arrived before the conquerors did in some cases.
In many cases, yes.
Yeah.
Pathogens were sweeping across the continent, decimating populations before Europeans even laid eyes on certain regions. So entire civilizations, complex societies were collapsing, sometimes literally into silence, before the European chroniclers even got there to write about them.
So they weren't documenting thriving cities, they were documenting, well, the aftermath. Ruins.
Precisely. They were often describing landscapes that were already in the process of being reclaimed by nature after unimaginable loss.
Okay, that idea of the landscape deception is really powerful. If the collapse was that fast, how quickly did the evidence of that huge agricultural network, the one feeding 60 million people, just disappear? Enough to convince later settlers it was pristine wilderness.
Well, the ecological rebound after a human population crashes that hard can be surprisingly fast. We're talking maybe within a few decades in many areas. Those vast, carefully managed agricultural landscapes, fields, terraces, orchards that had sustained millions they'd get overgrown, secondary forests would just surge back.
So what the later settlers saw and called untouched primeval forests
Was often, in reality, very fertile, recently abandoned farmland, highly managed land. They were essentially walking through an ecological recovery zone, a landscape haunted by a vanished population, not some timeless wilderness.
And the scale of this population collapse, this human catastrophe, it wasn't just a local tragedy, right? You're saying it actually had measurable global effects, even on the climate.
That's probably one of the most startling findings from recent interdisciplinary research. The scale of pre-Columbian human activity, particularly agriculture, was so enormous that its sudden stop had ripple effects across the globe.
How so?
Think about it. Suddenly, across vast areas of two continents, large-scale farming stops, managed burning stops. What happens? Massive reforestation. Trees grow back on an unbelievable scale.
And trees absorb carbon dioxide.
Exactly. This huge continent-spanning reforestation acted like a gigantic carbon sink, pulling enormous amounts of CO2 out of the atmosphere. Some climate modeling research now strongly suggests that this significant drop in atmospheric CO2 might have been a contributing factor, maybe even major one, to the global cooling period we know as the Little Ice Age, particularly in the 16th and 17th centuries.
Wow, so the scale of their civilization was so vast, its collapse literally helped cool the planet. That just underscores the sheer human footprint they had.
It absolutely does. It connects human history, agriculture, ecology, and global climate in a way that fundamentally challenges that old empty continent narrative.
Okay, let's zoom in on one region that the old narrative always painted as the ultimate wilderness, the Amazon. Impenetrable jungle, sparsely populated.
Right. The Amazon is perhaps the most potent counterexample to the colonial myth. Current demographic estimates suggest that by 1492, somewhere between 8 and 10 million people lived just within the Amazon basin itself.
8 to 10 million in the Amazon.
Yes. And crucially, these weren't all just small nomadic bands, the stereotype. Many lived in large, settled, interconnected population centers. We're finding evidence of towns, even cities.
But why didn't the Spanish and Portuguese chroniclers see huge stone cities like in Mexico or Peru?
Because Amazonian urbanism was different. It was often based on sophisticated management of the forest itself, using materials like earth, wood, thatch, things that biodegrade relatively quickly, especially in a humid environment. Their cities were often integrated into the forest, not built in opposition to it, so they left fewer of those monumental stone ruins that Europeans kind of expected to see. But the evidence of their presence, their engineering, their agriculture, it's written into the very landscape, into the soil itself.
Okay, here's where it gets really interesting, I think. When we talk about cities that could stand shoulder to shoulder with, or even look down on, European capitals, we have to start with Tenochtitlan, the Mexica or Aztec capital. It must have been just breathtaking.
Oh, absolutely. An absolute marvel of engineering, urban planning, and sheer organization for its time. Remember, it was built on an island right in the middle of Lake Texcoco, a strategic choice, but also an engineering nightmare.
And the population.
When Hernán Cortés and his men first saw it in 1519, estimates suggest it housed well over 200,000 people, maybe more.
200,000. How does that stack up globally at the time?
That likely made it the fifth largest city in the entire world, certainly dwarfing major European centers. Paris, for instance, probably had around 100,000 people then, and by all contemporary accounts, it was, shall we say, less organized and significantly less clean. London was even smaller.
I try to imagine the shock for those Spanish soldiers, coming from, let's be honest, often quite squalid and disease-ridden European cities. And then they see Tenochtitlan rising from the lake, especially the cleanliness you mentioned.
The contrast must have been stunning. European accounts, even those hostile to the Mexica, marvel at the city's order and cleanliness. They had a dedicated aqueduct system, actually two main ones, bringing fresh drinking water from springs on the mainland miles away right into the heart of the city.
So proper freshwater infrastructure.
Yes. And public sanitation was a major priority. They had public latrines available. They had systems for collecting human waste, often by canoe, which was then taken out to fertilize the chinampas, those incredibly productive artificial islands, the floating gardens they built in the lake. Nothing was wasted.
And actual public baths.
Public baths, yes. And beyond that, think about the daily upkeep. There are reports of a dedicated workforce, maybe over 1,000 people, whose only job was to sweep and wash down the public streets and plazas every single day.
1,000 street cleaners.
That's the figure often cited.
Right.
Compare that to 16th century London or Paris, where you'd be navigating streets filled with garbage, animal waste, maybe even open sewers. Tenochtitlan was, by all accounts, exceptionally well managed and hygienic for a city of its size at that time.
And just building it there on the lake required incredible engineering, didn't it? Dealing with water levels, flooding.
Oh, absolutely phenomenal hydraulic engineering. They constructed massive earthen dikes or dams, some running for miles, to separate the freshwater parts of the lake from the brackish parts, and crucially to control floodwaters. They built these long causeways, wide roads raised above the water, connecting the island city to the mainland, equipped with drawbridges for defense. And a whole network of canals served as the city's arteries for transport.
It sounds incredibly sophisticated.
It was. And here's the real kicker, the deep irony we touched on earlier. After the conquest, the Spanish, lacking the understanding or perhaps the will to maintain this intricate indigenous water management system, began to dismantle parts of it. They filled in canals, neglected the dikes, and imposed their own, frankly, inferior European drainage methods better suited to drier landscapes.
And the results?
Predictable disaster. Mexico City, built on the ruins of Tenochtitlan, suffered from persistent, devastating floods for centuries afterward. And the disruption of the clean water supply and sanitation systems contributed to terrible outbreaks of waterborne diseases like typhus. These were problems directly caused by replacing a highly adapted, sophisticated indigenous system with inappropriate colonial technology. The legacy of that poor decision still affects Mexico City's water management challenges today.
Okay, let's shift gears and go far south, deep into the Amazon again. You mentioned their urbanism was different, these garden cities. Not stone monuments, maybe, but still requiring massive coordinated effort.
Exactly. Amazonian urbanism wasn't about dominating the landscape with stone, but about intelligently managing and integrating with the forest ecosystem. Think of places like this Xingu Indigenous Park in Brazil, where archaeologists are finding evidence of networks of settlements. These weren't just villages. They were carefully planned, sustainable living areas interwoven with managed forests, orchards, fish ponds, and agricultural zones.
So the monuments were made of earth and landscape changes, not just buildings.
Precisely. The evidence for large, organized populations lies in the massive earthworks they created. These required mobilizing and coordinating huge amounts of labor, which implies complex social structures.
Can you give us an example of these earthworks? What did they actually look like?
Well, in the Llano region of Bolivia, which floods seasonally, ancient cultures built enormous raised fields for agriculture. These weren't just small mounds. Some were elevated platforms up to 30 meters wide, that's almost 100 feet, and stretching for hundreds of meters, even kilometers. They built causeways connecting settlements, canals for transport and drainage, all requiring moving millions of cubic meters of earth.
Just a farm above the floodwaters.
Exactly, and it worked incredibly well for centuries. Then you have defensive structures. We're finding large village sites, some covering up to 240 hectares. That's huge, surrounded by deep, wide ditches, sometimes 4 meters deep or more, essentially moats.
Like medieval European castles.
The function seems similar, yeah. Castle-like moats, protecting these large settlements. Now, who or what they were defending against, that's often still a mystery. But constructing defenses on that scale absolutely requires large populations, strong leadership, and sophisticated organization. You don't build things like that unless you have a stable society capable of massive collective projects and probably facing significant threats.
But perhaps the most mind-blowing example of their ecological engineering, the thing that really speaks to sustainability, is terra preta, this black earth. It sounds almost too good to be true.
It is remarkable, but it's very real. Terra preta, do Indio, Indian black earth, is found in patches throughout the Amazon basin, often near ancient settlements, and it's entirely human-made.
How did they create it? It wasn't just accidental accumulation of waste.
No, it seems to have been very deliberate. Indigenous peoples created it over centuries by intentionally incorporating vast amounts of organic matter, food scraps, bones, fish remains, manure, but crucially, also large quantities of charcoal and pottery shards into the naturally quite poor, acidic Amazonian soils.
Charcoal? Why charcoal?
That seems to be the key ingredient. This wasn't just ash from normal fires. It was likely produced through slow, low-oxygen burning, a process we now call pyrolysis, which creates very stable biochar. This charcoal is incredibly porous and doesn't break down easily.
And what does that do for the soil?
It acts like a sponge. It holds onto nutrients and water that would otherwise leach away quickly in the tropical rains. It also provides habitat for beneficial microbes. The result: terra preta soils are astonishingly fertile, maybe 3 times richer in organic matter than the surrounding soils, and with 70 times the charcoal content.
70 times?
Yeah. And the truly amazing part is its longevity and resilience. These soils remain incredibly fertile for thousands of years after they were created. Some studies even suggest they might be self-regenerating to some extent because the conditions they create encourage further microbial activity and carbon capture.
That's incredible. So they weren't just farming the Amazon, they were actively building better soil to support large populations sustainably.
Exactly. It's sophisticated ecological engineering. They transform their environment to make it more productive without destroying it. And that knowledge, how to create stable, carbon-sequestering, fertile soil in poor conditions, well, that's something modern sustainable agriculture and climate scientists are now studying very, very intensely. It holds huge potential for our own challenges with food security and carbon emissions. Okay, so we've seen incredible engineering and ecological management. But if we shift focus now to, let's say, pure intellectual achievement, the pre-Columbian Americas offer stunning examples of innovation that developed entirely independently from the Old World. We have to talk about the Maya, masters of mathematics and timekeeping.
Yeah, when you think Maya, you often think of those amazing pyramids, the intricate carvings, maybe the calendar ending. But you're saying their mathematical breakthroughs were just as profound.
Absolutely. Perhaps even more so in some ways. The headline achievement is their development and sophisticated use of the concept of zero.
Now, other cultures used placeholders, right? Like the
Yeah.
Babylonians.
They did, yes. But the Maya seem to have been among the very first, possibly the first, to use zero, not just as a placeholder in calculations, but as a true number in its own right. And more than that, it had philosophical weight for them. They had specific glyphs for zero, often a shell shape, sometimes a flower representing completion or potential, the start of a news cycle. It wasn't just an absence, it was a concept.
And having that true zero concept, centuries before it was fully grasped and utilized in Europe, what did that unlock for them?
It was fundamental to their entire mathematical system. They used a vigesimal system, base 20, rather than our base 10. Having zero allowed the system to function elegantly for very large numbers in complex calculations.
Which they needed for their astronomy and calendars.
Precisely. Their base 20 system, powered by the zero, allowed them to track astronomical cycles with mind-boggling accuracy. Their famous calendar wasn't just one calendar. It was this incredibly intricate, interwoven system.
Mm-hmm.
You had the 260-day sacred calendar, the Solkin. You had the 365-day solar year, the Hab, which they calculated with a remarkable precision. And you had the long count, tracking vast stretches of time.
And they could predict celestial events.
With astonishing accuracy for their time, yes. They tracked the cycles of the sun, the moon, Venus, possibly other planets, and could predict events like solar and lunar eclipses. This required sophisticated mathematics and meticulous long-term observation. And let's not forget, the Maya were one of only a handful of civilizations in all of human history, maybe only 4, to independently invent a complete system of writing from scratch. Their hieroglyphic script could record complex information from astronomical data to king lists to historical events.
Just incredible intellectual firepower. Okay, now let's swing south again to the Andes. The Inca Empire, Tonansuyu. You mentioned earlier it was the largest empire on Earth by land area when Europeans arrived. But the real mind-bender is they managed this vast, complex state without a written language as we know it.
That's the great paradox and the testament to their unique genius. Tonansuyu stretched something like 5,000 kilometers, that's over 3,000 miles along the spine of the Andes. An enormous territory, incorporating dozens of different ethnic groups and languages across some of the most challenging terrain on the planet.
Yeah.
Comparable in scale only to maybe the Roman Empire at its peak.
And controlling that, administering it required... Well, what did it require without writing?
It required incredible organization, centralized data management, and truly world-class infrastructure. The backbone was their road system.
Right, you mentioned the roads earlier.
Over 25,000 miles of engineered roads. And these weren't just trails. We're talking paved highways where possible, staircases carved into mountainsides, tunnels cut through rock, and truly awe-inspiring suspension bridges woven from ichu grass or reeds, spanning terrifying canyons. Some of these bridges were used for centuries.
And this network allowed them to communicate and move resources quickly.
Extremely quickly. They had a state-run relay messenger system using runners called chasquis. These guys were incredibly fit, operating in stages. A message or a small item could travel hundreds of miles in just a few days. Along these roads, they built strategically placed lodging houses and supply depots called tambos, ensuring the runners and traveling officials or armies had food, shelter, and provisions. It was a logistical masterpiece.
Okay, the logistics are impressive, but how did they keep track of everything? Taxes, census data, supplies in those tambos, without writing it down. That's where the quipu comes in, right?
Exactly. The quipu. It's one of those fascinating and still somewhat enigmatic pieces of Inca technology. Essentially, it's a system of knotted cords, usually made of cotton or camelid fibers like alpaca wool.
Knotted strings? How can that possibly store complex information?
It's ingenious. You have a primary horizontal cord.
Yeah.
Hanging vertically from that are pendant cords, and sometimes subsidiary cords hang off the pendant cords. Information was encoded in multiple ways. The type of knot used, the position of the knot on the cord, which often indicated decimal place value ones, tens, hundreds, etc., using a base 10 system. The color of the cords, the way the cords were plied or twisted together.
So it's like a three-dimensional spreadsheet made of string.
That's a pretty good analogy, yeah.
Mm-hmm.
A tactile three-dimensional database. They had specialists, the Quipucamiacs, who were trained from youth to create and interpret these quipus. They could record remarkably precise quantitative data, census numbers, detailed inventories of goods like grain or llamas, tax obligations, calendar information, maybe even engineering measurements.
Quantitative data, okay. But could they record narratives, history, laws?
That's the big debate among scholars right now. For a long time, the consensus was that quipus were purely mnemonic devices for numbers. But some researchers, like the late Gary Urton, argued convincingly that the system might have been complex enough, using combinations of color, not type and structure, to encode actual narrative or linguistic information, a true form of three-dimensional writing, unlike anything else we know. We're still deciphering the full potential of the quipu, but it's clear it was an incredibly sophisticated tool for managing a massive, complex empire without resorting to alphabetic or syllabic script.
Okay, we've covered engineering, urbanism, intellectual achievements, administration. Let's turn to political structures, because again, the narrative often implies, simple chiefdoms or brutal empires. But the reality seems much more nuanced, sometimes even, well, democratic in surprising ways. Imagine being a European used to absolute monarchs, then encountering something like the Haudenosaunee.
Right, the Haudenosaunee Confederacy, often known as the Iroquois League or Confederacy of Six Nations. This is a political entity founded potentially as far back as 1,000 years ago, maybe more, in what's now upstate New York and southeastern Canada. It united originally 5, later 6, distinct nations under a constitution known as the Great Law of Peace.
And this wasn't just an alliance, it was a formal political structure.
Oh, very formal. It was a sophisticated form of participatory democracy, designed explicitly to maintain peace among the member nations and provide a unified front against external threats. Crucially, it operated without political parties and featured complex systems of checks and balances to prevent any one group or individual from accumulating too much power.
How did it work? How were decisions made compared to, say, 15th century Europe?
Power wasn't concentrated at the top. Major decisions required consensus among the member nations, debated within a Grand Council of Chiefs or sachems. This council itself was structured. You have the older brothers, the Mohawk and Seneca, who would discuss an issue first, then the younger brothers, the Oneida and Cayuga, would discuss it. If they agreed, the decision went to the keepers of the fire, the Onondaga, for final confirmation or arbitration if there was disagreement. It was a multi-stage deliberative process.
That sounds remarkably advanced. Checks and balances built right in.
Exactly. Designed for stability and to prevent rash decisions or tyranny. But perhaps the most revolutionary aspect, certainly from the European perspective at the time, was the role of women.
This is the matrilineal aspect, right?
Fundamentally so. Haudenosaunee society was matrilineal lineage and clan identity passed to the mother. Women controlled agriculture and the longhouses where families lived. And critically, they held the ultimate political authority through the clan mothers.
The clan mothers weren't just advisors.
Far from it. The clan mothers selected the male chiefs who sat on the Grand Council. They instructed these chiefs on the positions they should take, reflecting the consensus reached within the clan. And this is crucial. The clan mothers held the power of impeachment. They could warn and ultimately remove any chief who acted improperly, failed in his duties, or went against the will of the people or the principles of the Great Law.
So the men held the council seats, but the women held the power to put them there and take them away.
Essentially, yes. No major decision could be finalized without considering the women's perspective, and ultimately their consent was vital. It was a system where political power was deeply rooted in the community and accountable through the women back to the people.
Which makes the historical irony almost painful, doesn't it? That figures like Benjamin Franklin looked at this sophisticated Haudenosaunee model of federalism and representative government.
Studied it, admired aspects of its structure for restricting centralized power, drew inspiration from it when thinking about uniting the American colonies.
And then proceeded to help create a system that systematically excluded women from political power entirely.
It's a profound contradiction. They borrowed elements of the framework, the idea of a representative council, checks and balances, federalism. But they completely ignored or perhaps deliberately rejected the foundational Haudenosaunee principle of women's political authority and oversight, which was key to its stability and accountability. They took the shell, but discarded the core mechanism.
Beyond these large confederacies, were there other models? You mentioned the Pueblo cultures earlier as having a different approach.
Yes, the various Pueblo peoples of the American Southwest represent another fascinating model, focused more on resilience through cooperation and flexibility rather than large-scale political union. Generally, each Pueblo village or town was politically independent.
But they interacted.
Very much so, especially in response to the harsh, unpredictable environment of the Southwest. During periods of severe drought or famine, which were recurrent challenges, different Pueblo groups would often provide refuge and support to one another. People might temporarily move to villages in better watered areas, forming multi-ethnic, multilinguistic communities for a time. Their political system allowed for this kind of pragmatic flexibility and mutual aid to ensure collective survival, rather than rigid borders or constant conflict over scarce resources. It shows a different kind of political sophistication based on interdependence.
Now, as we're highlighting these sophisticated systems, it's important, as we always try to do here at the Urban Herald, to maintain balance. We need to avoid painting a picture of a perfect utopia, right? These were complex human societies.
Absolutely crucial. Replacing the old myth of the savage wilderness with a new myth of a perfect paradise doesn't help anyone understand the reality. Pre-Columbian America was incredibly diverse, dynamic, and yes, often involved conflict, inequality, and brutality.
They were empires built on conquest and tribute, just like in the Old World.
Definitely. The Mexica-Aztec Empire itself relied on tribute from conquered peoples. The Inca expanded through military campaigns. There were long-standing rivalries and wars between major powers, like the fierce enmity between the Tarascan Kingdom and the Mexica Empire. There was social hierarchy, likely instances of oppression. It was the full spectrum of human social organization.
So the point isn't to say they were better or worse than contemporary Europe.
The point is simply to recognize that they were comparable. They were large-scale, complex, human civilizations operating with sophisticated political structures, intellectual traditions, large populations, impressive engineering, and yes, also internal conflicts and power dynamics, entirely on par with, and in specific areas sometimes exceeding, what was happening across the Atlantic at the same time. It demolishes the idea that one side represented civilization and the other wilderness.
Okay, this might be one of the most tangible legacies, something that affects literally everyone on the planet today. The food. Indigenous Americans weren't just farmers, they were master geneticists, weren't they? Transforming wild plants into global staples.
That's not an exaggeration at all. The agricultural contributions of the Americas represent a revolution in global food supply, perhaps the most significant transformation since the initial invention of farming itself. And much of it comes down to absolutely brilliant, millennia-long work in plant breeding and genetics.
Let's start with the big one, maize, or corn. You hear it called the greatest genetic engineering feat in history.
It's often cited that way by plant scientists, yes. And it's hard to argue. Modern maize is a purely human creation. Its wild ancestor is a grass called teosinte.
Teosinte looks nothing like corn, right? Tiny seeds, hard casing.
Exactly. It's barely edible. Maybe a dozen small, rock-hard kernels on a stalk. Transforming that into the large, soft, nutrient-packed cobs of modern corn, with hundreds of kernels. That took thousands of years of patient, highly observant, selective breeding by indigenous farmers, likely starting with peoples like the Olmec and Maya in Mesoamerica.
And this wasn't accidental.
It seems highly intentional. They selected for desirable traits, bigger seeds, softer casings, more rows of kernels, cobs that held onto the kernels instead of shattering. They did this so effectively that modern maize is now completely dependent on humans for propagation. It can't survive in the wild. By 1492, indigenous farmers had already developed thousands of different varieties of maize, adapted to virtually every climate zone in the Americas, from Canada down to Chile.
Thousands of varieties. Just incredible. Now let's go back to the Andes. The potato, another world changer.
Absolutely. Domesticated in the high Andes of Peru and Bolivia, the potato is another triumph of indigenous agricultural science, especially considering the challenging high-altitude environment.
And again, not just one potato, right?
Not by a long shot. Andean farmers, likely building on Inca state-sponsored agricultural science, developed an astonishing diversity. We're talking over 1,000 distinct potato varieties that we still know of today, and there were likely many more. Each one was carefully bred and adapted to specific conditions, different altitudes, soil types, frost resistance, storage qualities, even different colors and tastes.
1,000 varieties. That's resilience built right into the food system.
It's a masterpiece of maintaining biodiversity as insurance against disease, pests, and climate shifts. Compare that to, say, the Irish potato famine, which was devastating precisely because they relied on only one or two varieties.
And when the potato traveled out of the Americas, what was the global impact? It was huge, wasn't it?
Revolutionary. Potatoes are incredibly productive. You get far more calories per acre compared to grains like wheat, and they grow well in cool, damp climates and relatively poor soils, common in much of northern Europe. Once adopted, the potato fueled massive population growth. Some historical demographers estimate that the introduction of the potato was responsible for somewhere between 12% and 25% of all the population increase across Europe, Asia, and Africa between 1700 and 1900.
A quarter of the Old World's population growth possibly fueled by this one Andean crop?
That's the scale we're talking about. It fundamentally altered global demographics, allowed populations to grow, supported urbanization and industrialization, all thanks to the ingenuity of ancient Andean farmers.
And maize and potatoes are just the headliners. The list of crops domesticated in the Americas is just staggering.
It truly is a cornucopia. Tomatoes, all kinds of beans, kidney, lima, navy, pinto, squash, like pumpkin and zucchini. Peppers, both sweet bell peppers and all the chili varieties. Peanuts, avocado, sweet potatoes, cassava, or manioc, a vital staple in Africa and Asia now. Sunflowers, quinoa, vanilla, cacao, which gives us chocolate. The list goes on and on. These are now fundamental parts of cuisines all around the world.
And indigenous farmers developed sophisticated techniques to grow these, right? Not just planting seeds.
Oh, yes. Techniques like terracing on steep slopes, complex irrigation systems, raised fields like we discussed in the Llanos Tomoxos, and very famously, companion planting systems like the Three Sisters, planting corn, beans, and squash together.
How does that work?
It's symbiotic genius. The corn provides a stalk for the beans to climb. The beans fix nitrogen in the soil, benefiting all three plants. And the broad leaves of the squash spread out on the ground, shading the soil to retain moisture and suppress weeds. It's a highly productive, self-sustaining polyculture system.
All this diversity, these techniques, did it translate into better food security for them compared to, say, Europe at the time?
The evidence strongly suggests yes, generally speaking. While temporary shortages due to drought or other natural events certainly occurred, widespread, prolonged, catastrophic famines of the type that repeatedly plagued Europe seem to have been much rarer in many parts of the pre-Columbian Americas.
Why?
Primarily because of that agricultural diversity. They weren't reliant on just one or two staple crops like wheat or rye, which could fail entirely due to weather or disease. They had this huge portfolio of different crops adapted to different conditions, plus sophisticated storage techniques, like freeze-drying potatoes into chuño in the Andes. This created a level of systemic resilience and food security that European societies often lacked until they adopted American crops.
So putting it all together, the sheer population, the urban centers, the engineering, the intellectual leaps, the political systems, the agricultural mastery, it completely dismantles that old discovery narrative, doesn't it? That idea that Europeans brought civilization was essentially propaganda to justify colonization.
It becomes clear that it was exactly that, a justification. Europeans didn't arrive in an empty land waiting for civilization. They stumbled into a world that was ancient, complex, highly populated, and in many specific areas like urban hygiene, sustainable agriculture, certain forms of democratic governance, mathematical concepts arguably more advanced than contemporary Europe.
Okay, so correcting the historical record is vital. But what does revisiting this pre-Columbian history, doing this deep dive, mean for us today, living in the 21st century? Are there practical lessons?
Immensely practical lessons, yes. This isn't just about history. It's about rediscovering knowledge systems that offer crucial insights for tackling some of our biggest modern global challenges.
Like climate change and agriculture. You mentioned terra preta earlier.
Exactly. Terra preta is a prime example. The techniques used to create it, basically, locking carbon into the soil as stable biochar while dramatically improving fertility, are now being intensely studied by climate scientists and sustainable agriculture experts. Biochar production offers a potential way to sequester atmospheric carbon long-term, while also reducing the need for chemical fertilizers and improving soil health. It's ancient indigenous technology offering a cutting-edge climate solution.
And what about governance? We live in pretty polarized times, often focused on short-term political wins.
Well, look again at the Haudenosaunee model. That core principle of the Great Law of Peace, the requirement to consider the impact of decisions on the 7 generations yet to come, that's a profound concept.
7 generations.
Imagine if our modern political systems operated with that kind of long-term perspective, especially regarding environmental policies or resource management. It offers a powerful model for thinking about intergenerational equity, sustainability, and fostering inclusive, stable governance that looks beyond the next election cycle.
And the food resilience we talked about, that genetic diversity.
Absolutely critical today. Modern industrial agriculture relies heavily on monocultures, vast fields of genetically uniform crops. That makes our food supply incredibly vulnerable to new diseases, pests, and the impacts of climate change. The immense genetic library preserved in indigenous heirloom crops, those 1,000 potato varieties, the thousands of maize types, holds vital genetic resources. We need that diversity to breed new crop varieties that can withstand drought, heat, salinity, and new pathogens. Indigenous farmers weren't just feeding themselves, they were safeguarding genetic treasures that are essential for future global food security.
So a lot of the sophistication was just lost or hidden by the sheer scale of the population collapse and the forest reclaiming the land.
Largely, yes. For centuries, much of the evidence was obscured, either destroyed during the conquest, lost as populations vanished, or simply overgrown and invisible beneath dense vegetation, especially in places like the Amazon or Central America.
But now technology is allowing us to see through that veil. You mentioned LiDAR earlier.
LiDAR light detection and ranging has been an absolute game changer for archaeology in these regions. It's essentially airborne laser scanning. Planes fly over the landscape, sending down millions of laser pulses. By measuring the time it takes for pulses to bounce back, computers can filter out the vegetation layer and create incredibly detailed 3D maps of the ground surface beneath the canopy,
Revealing what was hidden.
revealing entire landscapes of human activity. Roads, canals, agricultural terraces, building foundations, even entire city grids that were completely invisible from the ground, or even using traditional aerial photography.
And the scale of these discoveries.
It's been breathtaking. It's forcing archaeologists to radically revise population estimates upwards in many areas. Take the recent LiDAR surveys in the Maya lowlands of Guatemala. They revealed a vast, interconnected network of cities, towns, farms, and causeways covering thousands of square kilometers, effectively a Maya megalopolis. Researchers identified over 60,000 previously unknown structures just in one study area.
60,000 structures. Supporting how many people?
The estimate suggests that region alone may have supported 10 million people or more during the classic Maya period, a population density comparable to or even exceeding many modern urbanized regions. LiDAR is showing us that the scale and intensity of settlement were far greater than we ever imagined based on excavating isolated sites.
And we're also pushing back the timeline for when people first arrived in the Americas, right? Confirming it's a much older story.
Yes, absolutely. The old Clovis first model, which held that humans only arrived around 13,000 years ago, has been effectively overturned by numerous discoveries. One of the most dramatic recent finds is the human footprints preserved in ancient lakehead sediments in White Sands National Park in Mexico.
How old are those?
They've been dated pretty conclusively to between 21,000 and 23,000 years ago. That pushes back clear evidence of human presence in North America by nearly 10,000 years. It confirms people were here during the last glacial maximum, a much earlier and more complex peopling process than previously thought. We are genuinely just scratching the surface now, thanks to these new technologies and a willingness to look past the old colonial assumptions. The history of the Americas is far deeper, richer, and more complex than the story we used to tell. #Chag outro. So to kind of wrap up this analysis from us here at the Urban Herald, it's clear the pre-Columbian Americas were anything but empty or uncivilized. We're talking about continents teeming with diverse peoples, incredible innovation, complex societies. Recognizing this true history isn't just about correcting the record. It's fundamental for acknowledging the immense contributions indigenous peoples made to global human civilization.
Contributions like foundational food crops that feed the world, independent invention of concepts like zero, pioneering sustainable urbanism, developing advanced political thought.
Exactly. And understanding what was lost, not just the people, but the knowledge, the libraries of ecological understanding, the diverse ways of organizing society.
It really makes you wonder, doesn't it? That question you raised earlier. How much further along might humanity be today, scientifically, politically, maybe even ecologically, if that encounter 500 years ago had been one of genuine exchange, of cooperation, instead of conquest and catastrophe?
It's a profound question. Think about the knowledge of sustainable living in diverse environments, like the Amazonian terra preta or Andean terracing. We're now desperately trying to relearn or reinvent solutions they had mastered centuries, even millennia ago, to face our current environmental crises.
Yeah, it feels like we're still playing catch-up in some ways.
We might well be.
You know, the ongoing public debate in many places about replacing Columbus Day with Indigenous Peoples Day, it really reflects this shift in understanding, this growing recognition of the history we've just discussed.
It taps right into this reassessment of who discovered whom and what civilization really means.
So as you, our listeners, go about your week, maybe consider this. When we learn about the sophistication of ancient American innovations from mathematics to city planning to governance, were those European explorers really encountering a new world? Or were they perhaps just arriving quite late to one of the planet's most ancient, dynamic, and incredibly innovative human theaters?